Now that we've actually been playing around with velocities and distance, let's actually do some more with the velocity part of it. So a particle moves in a straight line such that its position mx in meters relative to an origin O at time t of s is given, t seconds, is given by x of t equals 2 to the 3 minus 6t squared plus 9t minus 4. Determine the time t when the particle is at the origin. Alrighty, well, looking at the graph, since we've got t and x of t, we can see that it's at the origin, meaning 0 distance away, at 1 and 4. So for part A, we've got 2 times this happens, which is at time is equal to 1 and time is equal to 4. So in other words, at 1 second and 4 seconds. Alright, for part B, determine the particle's initial velocity. So just remember, for the word initial means when time is equal to 0. So initial velocity, well, that means we want to find v of 0, and our velocity function, v of t, is given to us as x dash of t. So let's work out the derivative of x of t. So we're going to get 3t squared minus 12t plus 9. So what's the initial velocity going to be? Well, that's going to be v of 0, and that's going to give us 9. 0 plus 9 equals 9. Alrighty, C, determine the time t when the particle is at instantaneous rest. Alrighty, well, instantaneous rest means when the velocity is equal to 0. So we're going to solve the other way around. So we've got 0 is equal to 3t squared minus 12t plus 9. Factorize out the common factor of 3, and we're left with a monic function, which has t-chart adds 2 numbers that multiply to 3, add to negative 4 has to be negative 1 and negative 3. So t minus 1, t minus 3. And these actually match up with our graph at the 2 points where we've got rest, once here and once here, at time equals 1 and time equals 3. Alrighty, so t is equal to 1 and t equal to 3. So those are our 2 points where the function is at a rest. Alrighty, describe the particle's maximum and minimum velocity over the interval 0 less than or equal to t less than or equal to 3. Alrighty, well, the first thing to do is to sketch the function. So let's do that. Alrighty, so we already know it's 2 t-intercepts, and we know its x-intercept, or its v-intercept. So we've got v of t up here, and we've got t down here, and we know that one of its intercept is at 1, another intercept is at 3, and its v, velocity intercept, is at 9, based on previous working out. And we can sketch the general quadratic shape. Now, another thing we might remember from our quadratics is that the turning point, which is going to be the lowest, or the most negative speed, is going to be halfway in between our 2 t-intercepts. So it's going to be at 2. Alrighty, so now that we've got our beautiful graph, the other thing we might want to know is then what's the actual y-coordinate partner? So let's work out v of 2. Alrighty, and evaluating that, we get minus 3. So the velocity at the turning point is at negative 3. Now, when we talk about maximum and minimum velocities, what we're really talking about is speed moving away from the origin and speed moving towards the origin. So we've got positive velocity and negative velocity. So the maximum velocity is just the biggest number, so the absolute value of this. And if you have a look, the maximum velocity is going to be when time is equal to 0. So at time equals 0, velocity is a maximum. Now, to think about the minimum speed, we really want to be thinking about what's the slowest speed you can go. because you can't really go negative speed. Negative speed doesn't really make sense. So instead, when we're thinking about the slowest you can move, that's actually when you're not moving at all. Because once you're going negative speed, you're really just going, you've got velocity just going in the other direction. So at t equals 0, we've got the velocity as the maximum, and at our two intercepts here and here, we've got our two minimums. Alrighty, so we've now worked out how to play around with our velocity function a little bit more. See you in the next one.